A very good morning to all of you. Today we are going to discuss part 3 of the two topics. We will see some of the AI problems, examples, water jet problem, missionaries and cannibal problem. So first we will discuss water jet problem. So in this problem, we are imagining we have a 4-gallon jug and a 3-gallon jug. So we need exactly through 2 gallon of water in either 4-gallon jug or 3-gallon jug. So, how do you measure it without any measuring device? In this problem, so we have two jugs, we can call it as X and Y. So, X holds maximum of 4 gallon of water and Y holds maximum of 3 gallon of water. So, here the state space is a set of pre-arranged pair giving the number of gallons of water in the pair of jug at any time. So, we can set it as X comma Y here. So X means water amount in the 4-gallon jug and Y means water amount in the 3-gallon jug. So where X can be 0, 1, 2, 3 or 4 and Y can be 0, 1, 2 or 3. So initial set we can set it as 0, 0. Initially both are empty and the goal state we can set it as 2, n. 2, n means there is 2 gallon of water in 4-gallon jug and 3-gallon jug, that can be anything. Next, we will see the problem space. So the state is represented as X comma Y. We already discussed X is the amount of water in jug A and Y is the amount of water in jug B. And here capital A means the capacity of jug A and capital B we are considering it as capacity of jug B. Initial state we are taking it as 0, 0, that is both jugs are empty. So we will see the actions and transition model. So the transmission model defines how a one state changes into another state due to an action. We already discussed. Then we are considering the first state as the X comma Y. So first transition we are considering it as fill A. So fill A means fill jug A completely. So it will become A comma Y. So the capacity of first jug is A. So A comma Y. Then second one is fill jug B completely. So that means X comma B. So the total capacity, maximum capacity of jug 2 is actually B. Then the third one is MD jug A. So it will become X comma Y become 0 comma Y. And then MG jug B. So X comma Y will become X comma 0. Then next is pour water from jug A to B. So that means amount transferred we have to calculate. We are calculating using the equation. Here we can see the equation, that is minimum of X comma B minus Y. So that means X is the amount of water in first jug and B is the capacity of second jug, that is 3. 3 minus the amount of water in the second jug. So we are calculating the minimum, that we are assigning to T, and pouring some water from A to B means this T, the amount T we are pouring from A to B. So that is reduced from first jug and added to the second jug. And next is pour water from jug B to A. So here also we are calculating the minimum value. Here what we are calculating is here y is the amount of water in the second jug and first jug actually the capacity is 4 minus its amount of water in the first jug. So we are calculating the minimum, that we are assigning to T, and that T value will be added to first jug and subtracted from the second jug. Then these rules ensure no overflow and no negative water levels. And next is goal state. So goal state means here goal is to obtain exactly Z liters of water either jug. So first one, it can be first jug is equal to Z and Y can be anything. And here second or another case is actually X can be anything and Y is equal to Z. Next, we will see the production rules for water jug problem. The previous class we already discussed water production rules. So we will see one by one. The first one condition is the current state is X comma Y, and if the condition is if x is less than 4, so that means 4 gallon jug is not full, then what we can do is we can fill the 4 gallon jug. So that means if our current state is 0, 0, then it can be 4, 0. And second case, second rule where our y is less than 3. So what we can do is fill the 3 gallon jug. So here our condition is x comma, current state is x comma y, and we can move to the next state, that is x comma 3. So for example, we can say that if our current state is 4 0, then we can make to 4 3. Then next is third rule is pour some water out of the 4 gallon jug. That means our condition is actually x is greater than 0. Then what we can do is we can pour some water. That means D, we can remove what amount D from first jug. That means pour some water out of the 4 gallon jug. Then we can see the fourth rule, that is pour some water out of 3 gallon jug. So that means if y is greater than 0, then what we can do is we can pour some water from the second gallon. We can remove some water from jug B, or we can empty it. Both are possible. Then next fifth rule is actually empty the 4 gallon jug. So that means if x is greater than 0, the same, this is both the same condition. But here what we are doing, here we are emptying the first jug. Here we are not emptying, we are pour some water out of the 4 gallon jug. And then sixth rule, that is also similar to fourth one. Here if y is greater than 0, then what we can do? We can empty the 3 gallon jug. So that means pour all the water from jug B on the ground. And the seventh rule, that is pour water from 3 gallon jug into 4 gallon jug until it is full. So that means if x plus y is greater than or equal to 4 and y is greater than 0. So if both conditions satisfies, what we can do is we can pour water from 3 gallon jug into 4 gallon jug until the 4 gallon jug is full. So we can write it as 4 comma and here it is y minus 4 minus x. So we can fill the jug A with water from jug B until jug A is full. So we can consider the example if it is 2 comma 3. Our current state is actually 2 comma 3. So what we can do is we can pour water from jug B to jug A. So we can make it as, and we can define the new state as 4 comma, we are filling the jug A, so it will become 4 and the second jug will become 1. So that is applying seventh rule. Next we can see the eighth rule. Here what we are doing is pour water from 4 gallon jug into 3 gallon jug until it is full. So here the condition is x plus y is greater than or equal to 3 and, and x is greater than 0. So here we are fill the jug B with the water from jug A until jug B is full. So for example, we can consider if we have 4 comma 2. First jug we have 4 and second jug we have 2. Then what we can do is we can fill the second jug. So we can make it as 3, the second jug, and then our first jug will become 3 because one like 1 gallon of water we are pouring from jug A to jug B. And next, ninth rule is actually pour all water from 3 gallon jug into 4 gallon jug. So if the condition is x plus y is less than or equal to 4 and y is greater than 0, what we can do is we can pour all the water from the 3 gallon jug into 4 gallon jug. So that is another case. If our condition is 2 comma 2, if our condition, the current state, we can consider it as 2 comma 2, then we can make it as we are filling the jug A. So that means it will become 4 comma 0. Then next is actually 10th rule, that is pour all water from 4 gallon jug into 3 gallon jug. So if the condition is x plus y is less than or equal to 3 and x is greater than 0. So what we can do is we can pour all of the jug A into jug B if it fits completely. So for example, we can say that if the case 2 comma 1 where we can make it as we are completely filling the second jug, and so the first jug will become 0. That means 2 gallon of water mm, we are pouring into jug B. And next, 11th rule, that is special case, pour 2 gallon from 3 gallon jug into 4 gallon jug. So here we have state is actually 0, comma 2. But what we need is if our goal state is 2, comma 0, what we can do is we can pour the 2 gallon of water into the first jug. That is, and this directly help reach the goal stage. Then 12th rule, that is state is 2 comma y, where 2 comma y means clear the 4 gallon jug for any further operation. So we are emptying the first jug. So these are the protection rules. So we will see one solution. So here initial case is 0, 0. Our 4 gallon jug and 3 gallon jug both are empty. Then here it is showing which rule we are applied. Um, we have already discussed the production rules. So which rules it is applied is also specified in the right column. So initially what we are doing is initially we are filling the second jug completely. So it will become 0, comma 3. Then we are pouring the water from B to A. So it will become 3, comma 0. Again we are filling jug 2. Then it will become 3, comma 3. Then after 3 comma 3 here we are pouring water from jug B to jug A, so it will become 4 comma 2 because 1 gallon of water we are pouring to jug A, so it will become 4 comma 2. Then we are emptying the first jug, so it will become 0 comma 2. Then after 0 comma 2 what we need, our goal state is the first jug we have 2, then second jug it can be anything, so we are pouring the 2 gallon of water to the first jug, so it will become 2 comma 0 and we reach the goal state. So there may be many solutions will be there. Now we are moving to the next example. Next we will see the next problem, missionaries and cannibals problem. So we will see the problem statement. 3 missionaries and 3 cannibals are present at one side of a river and need to cross the river. So there is only one boat available. At any point of time, the number of cannibals should not outnumber the number of missionaries at that time. It is also known that only 2 persons can occupy the boat available at a time. So here we have 3 missionaries and 3 cannibals. They all are present at one side of the river. They want to cross the river. So there is a one boat is there, but we have a constraint. That means only one boat available and maximum two people can travel. So at next constraint is at no point can cannibals outnumber missionaries on any bank. So we will see the state representation. We will represent it as M1 C1 comma B. That means M1 is the missionaries on bank 1 and C1 is the missionaries on the missionaries on the bank 1 we can represent it as M1, and cannibals on bank 1 we can represent it as C1, and board position we can represent it as B. And after applying any production rule, the resulting state must satisfy missionaries are never outnumbered any by cannibals on either bank. So we will see the production rules. Here we can see the list of production rules, 10 production rules. So we will see one by one. The first one, when the boat is on the left bank and at least 2 cannibals are present, then the 2 cannibals can cross the river together to the right bank. So here we can see boat is on the bank 1 and C1 is greater than or equal to 2. Then we can move 2 cannibals to the bank 2. Then second rule, a single cannibal can cross from the left bank to the right bank when the boat is available. So that means boat is on the left bank and bank 1 and C1 is greater than 1, then we can move one cannibal to the bank 2. Then the third rule we can see, two missionaries can cross together from the left bank to the right bank. So here, mm, the third rule, boat is on the left bank and missionaries, number of missionaries is greater than 2, then we can move two missionaries to bank 2. The transfer is missionaries safely when cannibals are not dominant. Then next fourth rule is actually here we are moving one missionary from left to right. So one missionary crosses alone from the left bank to the right bank. So this is actually rarely used because must we have to ensure the safety on both banks actually in this case because there is only one missionary is traveling to the other side and we have to always remember the constraint. Then the next we will see the fifth rule, that is move one missionary and one cannibal from left to right. So that means a boat is on the left side and number of missionaries is greater than one and number of cannibals is greater than one when the possible solution, possible action is one missionary and one cannibal cross together to the right bank. So it maintains a balance. So missionaries are never outnumbered. And sixth rule, that is move two cannibals from right to left. So two cannibals return together from the right bank to the left bank if bank 2 having number of cannibals is greater than 2. And sixth rule we will see, that is move one cannibal from right to left. So here bank 2 having number of cannibals is greater than 1, then a single cannibal returns from right bank to the left bank. So then you can see the eighth rule. So eighth rule, move two missionaries from right to left. And here bank 2 having number of missionaries is greater than or equal to 2, then two missionaries return from right bank to the left bank. Then next, we will see the ninth rule. There, one missionary move from right to left. So that means if our number of missionaries on the right side, that is bank 2, is greater than 1, then one missionary we can that return alone to the left bank. It is actually rarely used, must preserve safety constraints. Then the 10th rule we will see, move one missionary and one cannibal from right to left. So that means in the left side, left bank, or sorry, right bank, that means bank 2, number of missionaries is greater than 1 and number of cannibals is greater than 1. Then the one missionary and one cannibal return together from the right bank to the left bank. So that should maintain safety while bringing the boat back. Now we will see the solution for how we can solve. So we will see the initial case. Initial case, we have three missionaries and three cannibals on the first bank. Here we can see the first column, it actually specifies which rule we have applied from the production rules. So here and in the river 2 initially is 0. Nobody will be there. And first what we are doing is we are taking one missionary and one cannibal to the right side. That means bank 2. And then we are returning with the one missionary. So here we can see now our state will be there are three missionaries and two cannibals on the bank 1. And then we are taking two cannibals to the bank 2. So bank 2 will become three cannibals and bank 1 three missionaries. Then next step we are taking one cannibal from right to left. So now it will become uh, three missionaries and one cannibal on bank 1 and two missionaries on the bank 2. Next, we are taking two missionaries to the right side. So that means our state will become two cannibals and two missionaries on the right side. Then we are taking one missionary and one cannibal to the right side. So it will become two missionaries and two cannibals on the bank 1. Then we are taking two missionaries to the right side. So that means in the second bank 2, it will become one cannibal and three missionaries. Then we are taking this cannibal, one cannibal to the left side. So it will become three cannibals on the bank 1 and three missionaries on the bank 2. Then we are taking two cannibals to the bank 2. So it will become three missionaries and two cannibals on bank 2. We are taking one cannibal to the left side. So now it will become in bank 1 we have two cannibals and bank 2 there are three missionaries and one cannibal. Then we are taking these two to the right side. Now three missionaries and three cannibals all on the bank 2. So this is the solution for the missionaries cannibals problem. Thank you.